In this lesson, we will learn about the data types in R. We will learn how to create them, how to check an object to see the data type, and also how to change the data type from one type to the other. To begin with, I will introduce you to two functions, the class and the type of functions. These functions are used to check the data type of an object. Now, the first data type that I'll introduce you to is the character data type. And this is anything with a single quote or a double quote. For example, let's create a variable. Let's call this greeting. On printing greeting, we have hello there. And one thing you should note is that when this is printed, there are quotation marks at the edges. Now, to check what type of data type this is, you can use the class. And this is character. You can also use type of. And this is also character. Now, to make this a bit interesting, because people get confused a bit when it comes to things like this. What if we use a number? So let's create a variable. I'll call this my number. Remember, it's in quotes, and I'll call this 1 to 3. We print it out first. We have 1 to 3. And now let's check the class. And we'll see its character. If we also check the type of confident is also a character. Now, the thing with this is anything, as I said earlier, with a single or a double quote, it's a character, regardless of what that thing is. Let me give you another example. I'll call this another number. And yet, I'll just type 1 to 3. Now, if I check the class of this, we have numeric. And that's because it's not in quotes. But to make sure this is indeed a character, we can do it like this. And 1, 2, 3. Doing it this way, it replaces what we have here before. And now if we check the class, we have character. So this is a good introduction to what characters are. Anything that is within a double quote or a single quote, including symbols. My symbol, and I'll use a single quote here, plus. And if you check the type of or the class, you have character, as long as it's within a single or a double quote. Now to integers. Integers are whole numbers, and the way whole numbers are written in R, it's always having an ending of L. For example, I can say my int and 1 to 3. Although it looks like an whole number, but it's not an whole number. To make this an whole number, you need to include L in front, exactly like this. And now when you check the class, and you see that it's an integer. If you also check the type of, you get the same result. So any digit that ends with L, that's an integer. Now to doubles. Doubles allow us to store numbers as decimals. And to create them, you can write the number as it is, like this, 1 to 3. And if you check the class of my double, see it's numeric. And now you get confused that why is this numeric when we're expecting double? And that's because class and type of, why indeed to check the type of object we have. Type of returns the internal type, that is how the object is stored. For example, now we have rice, and rice can be jasmine rice, basmati rice, the long grain rice, which I think you should try, really sweet. And also we have glutinous rice, but all these are rice. The same goes for numbers. We have the integers, which are whole numbers, and we have double or floats, which are the high precision numbers, the numbers with decimal points. So if we check the document on class, we'll see that object class is a simple generic function. And if we check type of, so this is type of determines the R internal type or storage mode. So how an object is stored, that's what type of does. Now to continue, we can do 1 to 3.4, and if we check the type of this, we see that indeed it's also a double. Now for integer also, we could use exponent 1e5, then L. As long as there's L in front of it, it is recognized as an integer by R. And you can also do the same for double, and it's a double. Now for logical data types are true or false data type. So if you check the class of true, you see it's logical. If you also check the type of true also, you see it's logical. So there's a short form for this, true is T, the capital letter T or uppercase T. Then false is the capital letter F. So you can use F as the short form or T as the short form. Now, this is a good introduction to the different data type, but we can also test for a particular data type using the is dot data type. Now, I will include this section. Now, for the character data type, you use is dot character, and we check the greetings here, which we created earlier, and say that true. That's the result. So is dot always returns a logical as output. Let's check another num to see if it's a character, and it says it's true, and indeed it is true. If we print another num here, you see that we have this in quotes. What about if we check is dot character for my int, we have false. That means it's not character, and that's true. So for integers, you can use is dot integer, and I'll test for my double, and that is false, and that's because double is a double, it's not an integer. Then I'll check for my int here, that's true. So this doubles down to other functions such as is dot double. We also have is dot logical, and these are the ways to assert if you have a particular data type. To continue, we have coercion, or changing from one data type to the other. And what this implies, as I said, is you're trying to transform or change how R reads one data type into another. For example, you want to change a number to a character, or a character to a number, and to logical as it stands. So for characters, every other thing can change to a character, but character cannot change to every other thing. So for example, to change character, we use the as dot, or to change to any data type, we use the as dot. So for example, we have as dot character 2, 3, 4, and see that we have this in quotes. If we also try as dot character for the object my int, see that it is transformed. But if you look at how my int is printed, you see that it's without quotes, and here it is with quotes. So you can also do this for integers as dot integers. And one thing about transforming to integer is we need to be careful, especially if we are transforming from the character. Now we have the greeting, which is definitely strings here, the alphabet. So if we try to change that greeting, we get this warning NA, and that's because there's no number there. But if we try my num, then you see that we have the result 1, 2, 3. So we can also do this for the double. As the double, my num, it's going to change as expected, and you can change an integer to a double and a double to an integer also easily, and that you can do that without any issues because they both have digits in them. Now for logical, every number that is not 0 is true, only 0 is false. Now as the logical -1 is true, as the logical 1 is also true. Why every other thing is true, but 0 is false. And now for the alphabet, or for the characters, let's check as the logical greeting and see the results. See that it's NA, so it only recognizes, for example, as the logical. Now this is a string here. True here is a string and not true in itself. This is how true is printed without the quotation mark to show that it's a logical data type. Now if we check as a logical, if we try to coerce, we have it changed. And if we do that for false, it changes also. We can also do that with T, and we have no error. So these are some of the ways we can assert different data types which we have. There's also another data type which we'll discuss about further in future classes, and it doubles down on integers and characters because it seems like a combination of both data type, but it's actually a subset of the integer, and that is the factor data type. In this class, we have introduced the different data types, we've seen how to create them, and how to test to see if a particular data type is what we expect, and how to change from one data type to the other.